We're probably live. Cool.
Very good. So
Nice. Excellent.
And we've got like 6 minutes to spare. I don't
Yeah.
know if everyone hear us fine on Zoom, I suppose. And so you've got about 45 minutes. Is that what we
Yes.
agreed?
Yes. That's timing wise. That's where it came in. It should be.
45 minutes. Sorry, I was getting some feedback from YouTube.
Oh, sure. Yeah, no, yeah, 45 minutes. Yeah, that's what I'm expecting, unless something strange happens.
No, that's wonderful, and we'll have some time for a question at the end. I'm going to, those of us who have already joined. I mean, I'm gonna give some introduction, also giving some instructions, but I would encourage the participants to already type some questions in the chat ahead of time. But then they will be able to also to ask questions. But I found that that's quite helpful sometimes. Questions come in already a little bit ahead of the Q&A session at the end.
Lets you not spend the talk thinking about the question that you want to ask when you get to the end of the talk. I hate it when I do that. I always do that.
Well, but don't get distracted by the chat. I guess if it's okay.
I'll leave it closed, and we can wait on them till the end. Yeah, okay. That's safest.
Okay, that's good. So we can wait for another few minutes. Perhaps I would suggest that you stop sharing the slides first, and I will ask during my introduction, perhaps the people who like to connect their videos, they could do so, so you get a bit of a sense of who's attending, and then I think people will turn off their videos for during your talk. But I think it's sometimes really a little bit awkward otherwise.
Sure, that's great.
With Zoom, so that's what I would suggest. I see that Yolanda, my colleague Yolanda, also co-organizer of the BIG, has turned on the video. Yolanda, you'll be chatting with Charles tomorrow, right?
Yes.
Yeah. Yes.
Wonderful. Yeah. Beatrice also joined. Hi, Beatrice.
Yes. Hello.
Did you have a chance already to talk with meet Charles earlier?
That's yes, wonderful. A very nice discussion.
It's been fun. It's been a fantastic day so far. I'm already very, very grateful. So.
Okay, wonderful. So yeah, for those of you who are joining now, I'm suggesting to turn on the video at the beginning. I mean, if it's practical, I understand it may not always be practical. Don't feel obliged, but if it's practical, turn on your video so that Charles gets a sense of of the participation, and then we will you can turn these off during the talk afterwards. But it's wonderful to see so many of you joining. We're also live streaming this on YouTube. So watch your language, everybody. And okay, that's wonderful. Some colleagues I haven't seen since before the confinement. So it's very nice. Okay, let's wait for another 2 minutes. I would suggest that you all mute, perhaps except for Charles and myself for the introduction. But if you can, do keep your videos in for now, your video feed. I think that's very nice. Way of welcoming our speaker today. Hi, Nico.
Hey.
Oh, very nice to see so many people. I see Ted, so also co-organizer of this series, actually, since the beginning perhaps, initiator of this series, also joining us. Hi, Ted.
Hi, Christophe.
Wonderful. Okay, well, so it is 4:15 sharp, and we love to be on time in Switzerland. So let's get started. At least with my introduction. So it's very nice to kick off this new season of big seminars. You know, we have quite difficult conditions. But we nevertheless felt it was important to try to carry on with you know, life as usual, as much as we can, and in particular this series of seminars which are across the different departments, and which I suppose also to bring us a little bit outside of our comfort zone and stimulate new ideas and connections. And so I'm really pleased that Charles Pence accepted to join today. So Charles is based now in Belgium at the Université Catholique de Louvain, UCL, in the other UCL in Belgium. He's North American originally, read philosophy at Princeton, and then obtained a PhD at the University of Notre Dame in Indiana, still in the US. Then worked at Louisiana State University before making the bold step of crossing the ocean and coming to Europe. Yeah, so it's very nice to have Charles with us. He specializes in the philosophy and the history of evolutionary biology specifically, which is of course of interest to all of us. Also very nice. Perhaps can I ask everyone to perhaps mute? You can keep the video on while I'm doing this introduction, but please mute. Else there will be a bit of noise. Yes, so also on this occasion, I want to welcome some colleagues also from the humanities faculty. I reached out to some colleagues in philosophy also. Hopefully, I know that some of you are joining, so that's really wonderful. So Charles helping us also build some bridges within our own institution. So I'm not going to say anything more by way of introduction, other than really pleased that we could do this meeting. We've tried to do it in person, but international travel is really too difficult. But I'm really happy to see so many of you now. I see over 90 participants on Zoom alone. So that's really wonderful. I encourage you then to turn off your video during the talk, stay on mute, but do use the chat function. If you already have some questions, Charles will take them at the end, unless we are in a situation of force majeure, which I don't expect it to be. But it's quite helpful already to have some questions and to stimulate. And I know some of you maybe like to take your time to think of like some questions. And so I think it's nice to have them already in the chat, but there will be opportunities to ask questions at the end, also either even with your video feed, or if you just want to type them, I can read them. Okay, so wonderful, Charles. I pass the control to you.
Yes, let me get my slides shared here again. Make sure that this looks right. Those coming in okay?
It's perfect.
All right, cool. All right, let me also, for the sake of keeping things so delightfully on time, let me start my stopwatch here. So yes, thank you all so much. I really can't tell you how much I appreciate the invitation. As a philosopher of science, philosopher and historian of science, it's really a fantastic opportunity for me to get to have the chance to chat with some proper biologists, as we like to say. Now this is really great, and I really appreciate doubly. I know that we are all between conferences and events and talks moved online, and the never-ending parade of hybrid and co-modal classes and whatnot. I know we're all a little tired of playing the lots of video faces in a box Zoom game. So I really appreciate how many people are taking the time to be here this evening. So thanks a whole lot for that. I really, you guys don't know, it means a lot to me. So let me, a little bit more about me. So yeah, basic biographicals already done, but just to say a little bit more. So yes, I work primarily on questions in the philosophy and history of evolution, as you've heard. I've also got a research group here, and I owe a lot of thanks to them, especially to postdocs Oliver Lane and Luca Ravelli, who've been working with me on this project in digital humanities. And I'm going to say a little bit more about what it means for a philosopher to be doing digital humanities here in a little while. So that's a bit more about me. I've gotten a chance to talk to some of you already today. I'll be talking to a few more of you tomorrow, again, for which I'm also very grateful. So thanks so much for your time for that. And feel free to reach out. Those are a pair of Twitter handles, one a bit more personal and one a bit more pure professional. If you don't want to hear my complaints as an expat, then you can follow the lab group Twitter there as well. So let me tell you a little bit about what I'm going to do today. So what do we want to talk about? There's the abstract. This talk is a sort of whirlwind tour. It's probably ill-advised. I'm probably doing more than it's possibly reasonable to try to talk to you guys about in 45 minutes, but I'm going to do it anyway. It's the kind of thing that I always do. I'm not known for making good decisions. So I want to try to package together a little bit of history of biology, a little bit of contemporary philosophy of science, a little bit of more general thinking about explanations in biology, as well as some connections between biology and society, biology and ethics. The goal really is, not to either bury you in philosophical jargon, nor to sort of preach at you about how science needs ethics or science needs philosophy or something. I really want to try to find a sort of connection with an interesting, sort of exciting, understudied aspect of the way that explanations work in the biological sciences from a really a sort of integrated historical and philosophical kind of perspective. And I'm going to talk about that through the lens of this notion of breadth that I think is really interesting. I think it's philosophically complicated. I think it's ethically complicated. I think it's societally complicated as well. So I think it's really worth sort of unpacking and spending some time thinking about. Another reason that I'm really happy to do this today, this is the sort of very, very early days of a book project that I'm theoretically going to start turning toward over the course of next calendar year. So it's really fun to get you guys' opinions on how this sits at this early stage, to hear from the people who are out there doing the real work in the trenches. That's really important to me as well. So again, the fulcrum that I want to push on for this to talk today is this idea of breadth. So you all know this, I suspect, that this is a thing that biology is sort of famous for, right? But I think it's important to think clearly about what it means and how we ought to engage with it. The first way to make this point really intuitively is just that biology is supposed to deal with all kinds of, there we go, sorry, with all kinds of stuff. right? So we can start with, the stuff that the person in the seat on the airplane next to you thinks that you do when you tell them that you're a biologist, right? And it probably looks like this, right? Oh yeah, so you think about coral reef, or maybe you think maybe it's rainforests instead, right? Some sort of really charismatic, shiny ecosystem that looks good on the cover of National Geographic, right? Filled with some delightful, charismatic megafauna, and that's what everybody looks at, right? Um, and I mean that's nice as far as it goes, of course, but somewhere underneath here, this kind of classic public perception of what the biological sciences are about is a really kind of interesting claim, because in addition to that stuff, which of course some of you here probably do work on that stuff all is supposed to form part of the biological sciences. Other things too are supposed to form part of the biological sciences, many of them very interesting. So this is here you've got a nice my favorite circular tree of life out of the Hillis lab. This is one of my favorite diagrams, right? Biology is about all of this stuff, and not just the stuff on the surface of this circle, but the entire center of the circle too, right? The entirety of the tree of life, not just at the present time, but going all the way back as far as we possibly can. Uh, it's probably worth pausing for a second, stepping back and thinking clearly about the fact that that's just a mind-bogglingly wide array of stuff. Think about how much stuff that actually is. It's also, though, and now we've talked about, full-sized organism type things. It's also supposed to deal with things that look more like this. Here's a figure from one of the first books to be illustrated with photographs of tissue sections from the late 1920s. It's a great story in the history of science because they left them looking a little raggedy and unprepared so that you would believe them that they were real photographs, right? It's a really neat historical document. It's also maybe supposed to deal with stuff that looks like this. So we've all seen diagrams. Happens to be some, psychoactive drug diagram working across the synaptic gap, as these things are wont to do, right? Now we're all the way down to the level of little bits and bots of biochemistry working in concert to produce biologically relevant effects. That's all stuff that's actually made out of, squishy biological bits, as many of you that I've already talked to today are fully aware as what you do for a living. It might even look a little more like this. I love this. I got to know some of the people working on this simulation back when I was a graduate student. This is macaques on an island in Indonesia. This is an individual-based model. And you've got forest resources here. You've got unforested resources. You've got water. You've got cities. You've got various different kinds of terrain. I want to say that they wound up modeling roads here. There's like a prospect that the macaque's going to get hit by a truck when it crosses a major road. This is all in silico, right? So this is a computer program. This might be part of what the biological sciences look like to you. And so to step back even farther, right? Every biology textbook this is from Harcourt's intro undergraduate bio textbook. Every bio textbook has a figure in it that looks something like this, right? And this is all supposed to be stuff that's about biology, right? Except for some of the atoms, or all of the atoms there at the bottom, and some of the molecules. The smaller, less interesting molecules. Okay, maybe those aren't part of the biological story. Everything else, from big molecules to the biosphere, gets to be part of biology, and that's just actually crazy if we pause for a second to really think about what we've done, right, in drawing up the boundaries between these different kinds of sciences. There's a whole lot of things that biological theory is supposed to be able to give us traction on. And at a really sketchy and intuitive level, we might look at two sort of different ways to start to flesh that out. Right? We might talk about horizontal breadth. So biology is supposed to deal with stuff all the way across the tree of life, both present and historical species. And we got this sort of more vertical notion across scales of organization that are going all the way from the ecosystem down to the biochemistry. And all of that is supposed to be sort of encompassed by the biosciences. But this is a really sketchy notion, right? So what we philosophers like to spend way too much of our time doing for a living is starting with a kind of sketchy, intuitive idea like these two concepts of breadth, and really trying to figure out what we mean. So what are we actually talking about? What really is breadth in this kind of sense? And once we figure out what that is, I'm gonna, I hope to show you over the course of the next 45 minutes or 35 minutes now, we're going to get some really interesting questions that we need to deal with about how biology and philosophy of biology are supposed to deal with the way that this concept appears in the practice of the science. So when we look for broad explanations in life science, what are we really doing? How should we understand what we're up to? Now, I am a philosopher and historian of biology. He's just out of frame. My camera is turned, or you would see the Darwin on my wall over my right shoulder right now. We're all borderline obsessed with Darwin. On the one hand, of course, for possibly problematic reasons, there is of course a little bit of hagiography in the philosophy and history of science, but also for very positive reasons. For those of you who've had the chance to really engage with some of Darwin's work, I think it is really impressive just how perceptive, even at the end of the 19th century, Darwin really was. The vast majority, as I often tell my students, I'm in fact about 2/3 of the way through The Origin of Species with another class of fresh-faced master students in philosophy right now. The vast majority of the really interesting problems in the philosophy of biology that we still deal with on a daily basis are fully present, maybe in an embryonic form, maybe in a weird form, a sort of Victorian 19th century inflected kind of form, but they're there in Darwin. And so I think it merits our attention. And what I want to do is I want to start with two different Darwins. I want to start with the Darwin that you know if you haven't done much Darwin, and then a Darwin that you might not know unless you've studied a fair bit of Darwin. Now, the first Darwin is young Darwin. I like showing this picture because he doesn't have a beard. This is a sketch of Darwin about the time he gets back from the voyage of the Beagle around the world in the 1830s. And this is the Darwin that writes The Origin. So over the course of the late 1830s, after he's back from that trip, he starts to open his first notebooks in which he starts to speculate about ideas of what we might call at the time, because it's not really evolutionary theory yet, he hasn't really developed evolutionary theory yet, what we might call transformism, to emphasize its connections with prior work of people like Lamarck. Now, that Darwin, this is the Darwin of the course of those notebooks, and after a 10-year break that I could go into, but won't because this isn't really a history talk, turns to, after a shock, worry about being scooped by his colleague Alfred Russel Wallace, many of you probably know the story, to very quickly writing what he will call the abstract of the book that he wishes he could have written, The Origin of Species. I like the idea that the 450-page Origin of Species is the abstract of the thing that he wishes he could have written. I for one, think we are probably better off with the abstract. Now, when you look at The Origin, and this I suspect at least a decent number of you have had the opportunity to at least flip through, at least catch some highlights. If you're catching highlights, probably one of the things, especially as a contemporary author, God knows we can't do this in our publications, you would notice is that in this entire 450-page book, there is exactly one figure. You probably can't get quite the resolution on this that you need at distance over Zoom. But suffice it to say, what you have here is a phylogenetic tree. It looks pretty much like any phylogenetic tree we might still draw today with slightly different typographic conventions. You've got about a dozen nodes down here at the bottom that are labeled with big capital letters, A through L. You've got a bunch of branching that goes on as we come up. Mostly Darwin's focusing on the offspring of two of those species, two of those nodes, A and I. I don't want to say species for a very particular reason I'm about to explain. And then there's these horizontal marks that are supposed to indicate time. They're labeled with Roman numerals from 1 to 14. And so we have the sort of species at time, or the nodes, excuse me, I keep doing that. We have the nodes at time 0, and we have the nodes at time 14, and we have the evolutionary connections between them. But precisely the interesting thing about this diagram, and this is what makes it so useful for Darwin, is that there aren't any real concrete labels There are only abstract labels on this diagram. There are only capital letters, small letters with little numbers for generations, and or for time points, and then the time points themselves that are Roman numerals down the side of the page. There's nothing like a real species here. There's nothing like a division into taxonomic levels, levels of the taxonomic hierarchy. There's nothing like a classification. This is a purely abstracted diagram. And what this lets Darwin do is something that's in fact one of my favorite moves in the entire book. I really always underline this whenever I get the chance to talk about the origin in general. In the course of just a few pages, he builds what I sometimes like to call an argument by or even. Right at the very first, when he first introduces the diagram, he says, so imagine that these the nodes across the bottom are sort of similar domestic varieties. And then imagine that the time points up the side of the diagram are something like 1,000 generations. And if you imagine variation accumulating in a small group like that for a small period of time like that, well, maybe, hey, by the time you get to the top of the diagram, maybe you have a subgenus or even a distinct genus. So nice little small amount of accumulated variation. Maybe you start to break a genus in half. Same page though. Well, now maybe think that that's not 1,000 generations, but that's 10,000 generations. And if it's 10,000 generations, then well, maybe they're actually very distinct genera or even distinct subfamilies. So all we did was extend the time, right? We have the same process. We have the same theory of natural selection accumulating individual variations, just the same kinds of individual variations that were present between our domestic varieties. And we've gone from subgenus to subfamily. And by 2 pages later, maybe we have, whoa, oh no, is my screen sharing still on? I'm sorry, could someone, I feel like my screen sharing vanished.
Sorry, yeah, you try to share it again.
Yeah, let me reload here.
Security. Sorry about that.
No, you're fine. I'm glad I caught it. Are you seeing the screen? Oh no, wait, I see you're seeing the screen now, but I'm not in presentation mode. Now we are good. Are we back?
Yeah, perfect.
Okay,
perfect.
Cool. All right. By just a couple pages later, right, we go all the way to, well, now maybe we think about this happening for an extremely long period of time. We start thinking on a geologic scale. And maybe we have 2 distinct families, or we even talk about having created different orders over the course of a period of natural selection. And this, I want to say, is a sort of first strategy for dealing with breadth, right? This is Darwin this is Darwin the Generalizer. This is Darwin trying to build a single theory. So I'm going to tell you about one process, natural selection, plus, and again, I could go into this if this was a proper pure history talk, perhaps the divergence of character, which is no longer a part of contemporary evolutionary theory, but let me leave that aside for the moment. I'm going to show you one process that if we iterate it over time, if we think about it operating in a substantial enough manner over geologic time, we're going to get all of the kinds of outputs that we want in terms of the structure of the tree of life, taxonomic hierarchy of groups nested within groups. This is Darwin building big theory. Now let's talk about another Darwin. That's Darwin number 1. Let's talk about Darwin number 2. Here's Beard Darwin. Beard Darwin had to make an appearance. This is post-origin Darwin. So after the origin comes out, of course, Darwin thankfully decides not to write the massive book that he was hoping he would write anyway. Much of his effort in this later period, with the exception of The Descent of Man, which you probably have heard of and maybe even have had the chance to read, especially if you work on human evolution or group selection, it's really cool stuff in there. But much of his effort in this later period goes to stuff you probably haven't read. So just to pick one example, 3 years after the origin, let's look at this book. So this is on the various contrivances by which British and foreign orchids are fertilized by insects and on the good effects of intercrossing. We call this the orchid book. I don't know if any of you have looked at this. So maybe I know there's some plant biologists in the audience. Maybe the plant biologists flipped the orchid book. The orchid book is really cool. I really like the orchid book. there's a sense in which, if you want to compare what Darwin is up to what you guys actually mostly do every day, to what real practicing biologists' job is, the Orchid book is more Darwin doing real biology than the Origin is, right? You guys aren't mostly spending time trying to derive novel theories to explain the origin and distribution of variation in life over the history of geologic time. I don't think. This is nuts and bolts biology, right? This is good old-fashioned biology. And what he does is he fills this book with masses and masses and masses of data, detailed observations of orchids, in particular, the crazy ways in which orchids get fertilized by insects. Now, he has a theoretical goal here. So if you've read The Origin, one thing that you know that he tries to argue for is the idea that even species that you might think were purely hermaphroditic in the long run are in fact not. That almost every species intercrosses at least sometimes. Now, why is that important for Darwin theoretically? Well, intercrossing, he wants to argue, is going to generate variation, and variation is going to be the raw material for natural selection. So it's important for him to be able to say that you never get sort of permanent self-fertilization on into the future, which was a going theory among some botanists, especially for really weird plants like the orchids, where you have these bizarre flowers that look like there's no way that anything could ever fertilize these except their own pollen. And so this is Darwin's goal, is to show that no, even in these crazy cases, like this guy, you have the possibility for fertilization. He also throws in some cool other arguments, just to mention this because it's neat. This is the bog malaxus. This is Malaxus paludosa, which is interesting precisely because here he is in real life. He opens up his flower. Obviously, these aren't flowered yet, so which is kind of sad. But he opens up his flower. Now, many orchids, Darwin notes, turn around through 180 degrees. They do this, he argues, precisely because it creates a nice little landing spot for bees to be and various kinds of insects to be able to land and fertilize them in the long term. What's weird about this thing in particular, though, is that it opens its flower, it turns through 180 degrees, and then it keeps turning all the way through 360 degrees and winds up back exactly where it started. Now, this, for Darwin, okay, great argument against special creation, right? Why would you design something to spin all the way through 360 degrees and wind up back where it started again? There's absolutely no reason for it. Must have just been changing selection pressures, right? So they started building the 180 turn, and it turns out that the variation that was accessible after they built 180 degrees of turn was just to keep going. It was easier for evolution to go ahead and push through 360 than to stop. Cool. All that's neat. This is all like okay, I'm doing like my infomercial pitch for the Orchid book right now. But there's another aspect here that I think is really important. I think what I want to say here is that this is Darwin doing what I want to say is 19th century big data. This is what amounts to Darwin the data analyst. Here is a contemporary phylogenetic tree of the orchids. I am officially not a botanist, so I sincerely apologize. I'm probably going to butcher at least something coming up here. But here's a contemporary phylogeny of the orchids, and this much I am confident in. Everything that you see colored in orange here is a group that Darwin gives you at least one exemplar of over the course of the Orchid book. That's a ridiculous amount of coverage for the late 19th century. Darwin had people boxing up orchid specimens and sending them to him from literally all over the world to be able to build the kind of analysis that he runs in here. It's a crazy, crazy number of species that he starts to draw out. I want to say this is Darwin the big data analyst. This is the other thing that you can do when you're faced with a problem of breadth, right? You can either do what Darwin did in The Origin, you can try to build generalizable theory, or you can go the other way. You can get the nasty data, you can get the broad scale, the wide scope, hard empirical data collection that you want to understand, that you need to understand a particular group, and you can work through the nasty analysis yourself. And so I want to say here that you see two different approaches to ways that you might deal with a problem of breadth. You might call it like big theory versus big data, right? Origin Darwin versus orchid Darwin, or generalizing versus analyzing, right? These different pushes that we have in the construction of scientific theories. We have to theorize past it, or we analyze it all in one fell swoop. So there's a little history of science, kind of way to open up this sort of problem that I want to talk about today. The thing I want to do now, rather than, so I could give you an example from contemporary big data biology, but that actually seemed silly to me. I'm talking to a Zoom room full of biologists. I don't need to give you an example of contemporary big data biology. What I might need to do, though, for those of you who haven't already talked to me today, you would absolutely be forgiven for sitting on the other side of your computer right now, asking yourself, what do you do? What does a philosopher of biology actually do? And so I wanted to approach that question. I wanted to give you an example from my own work, because I think it actually echoes very nicely the same kinds of challenges that you find in contemporary biology, insofar as, we're trying to understand what you guys are doing. If there's a challenge in the contemporary biosciences, it's going to be mirrored in many cases in the way that philosophers try to approach biological practice. So I want to use this opportunity now, the second chunk of the talk, to give you a bit of an introduction to some of my own work. So let's talk about a random question. Let me pick something out of the hat that a philosopher of biology might deal with. Here's a classic one, a sort of basic conceptual analysis problem. There's lots of different concepts of biodiversity in the biological literature. It's just one of those concepts, I think everybody knows this, right? You get 10 conservation biologists in the room, you're going to have 15 different ideas about what biodiversity means, what kinds of proxies might measure it, what kinds of empirical approximations might be particularly relevant to let you get a handle on what you're trying to do. It's a classic kind of conceptual morass, and philosophers like nothing better than sort of wading off into a conceptual morass and trying to understand what's going on. This is one of our classic tricks. And the problem of generalizing versus analyzing is exactly the same for us doing the philosophy of the science as it is for you guys doing the proper science itself. So the traditional way that we've done philosophy of science for a very long time is this generalizing idea, right? This is what philosophers are trained in. It is our bread and butter. Pulled again a couple of examples out of the hat, a couple of papers on this question that I really like. A great essay review of a book by Jack McLaurin and Storelny, review by Jack Justice on the various different concepts of biodiversity. So this is sort of cross philosophical biological work being reviewed by a philosopher. But the basic idea, it's exactly another one of these. Let's catalog all these concepts, try to understand them, figure out what they have in common. Or a great article by the philosopher, I should say, at University of Utah, a good friend of mine, Carlos Santana, who says, look, forget biodiversity, just eliminate this idea. This is a concept that's actually, if you look at biological practice and the kinds of social and ethical practices that are obviously linked to the use of biodiversity concepts in the wild, you'll realize we should just throw this out. This is a dangerous notion. It's getting in the way of our conservation goals. It's a great, really provocative paper. I really like it. So again, this is a perfectly plausible method, right? If we want to be able to use this kind of a notion for policy making, which it seems like we do, we better know what we're talking about. So we could approach this from a kind of generalizing perspective. I can try to tell you what the foundational analysis of biodiversity is. And maybe I can show you how some pieces of biological practice sort of instantiate that, give rise to that kind of foundational notion. On the other hand, though, you might take the other approach. So you might take a big data approach. You might take an analyzing approach. And this is something that I've been trying to build among my own research group in an increasing amount here in the last few years, especially since moving to Belgium. I've really been trying to lean into this because there's been a lot of delightful uptake of this idea here in my new position. What we've done is we've constructed what for now is called, I'll say a little more about this in a second, the EvoText project. This is a corpus of about 1.6 million journal articles in the biosciences. So we called it EvoText at first. They're almost all in the biosciences. that lets you run various interesting kinds of textual analysis on the biological journal literature. So if you want to know what people are saying about biodiversity and how they're using it, well, you can turn to the texts. You can go look at the journals and you can see what the journals say about the concept of biodiversity. You can back up or perhaps replace, and this is the interesting question, right? We'll come back to this in a little while. Your generalizing approach with a big data approach about the science, right? Now, whereas since I'm a philosopher of science, my data is you guys. You are my data. Your papers are my data. So I'm trying to analyze that to understand what's going on in the scientific process. Look out for a new version of this. My research group over the last year, we've been working on a brand new shiny upgrade to this. We've realized that it's actually useful for many things more than just the biosciences, because we have a lot of general science literature in here, like nature. So it's going to be renamed to SciVair, expanded. It's got better data quality. We're going to have some data sharing agreements in place. So like if you want to work on the same kind of stuff, get in touch. Watch this space. I'm hoping for that to start rolling out by the end of the year. So that's exciting from our perspective. So what would this look like in this particular case? Well, imagine we go look for biodiversity, and this is biodiversity in the entire corpus. And it doesn't exist in 1985. By the late 20 teens, notably our data, we start to run out of data after about 2012, 2013. So you may not believe as robust a manner these later articles, later years of article data. But by the end of the graph, you get to 15 or 20% of articles. That's a hard fraction. Sorry, I didn't label my axes. Scientists are going to kill me. That's a fraction of articles there on the y-axis. You get to nearly 20% of articles making some kind of reference to the concept of biodiversity. Now, this squares with the history that we have. So for those of you who know, the concept does actually get invented in the late 1980s. It really picks up steam right around 1990. It both starts being used by E.O. Wilson, who of course is just so famous that when E.O. Wilson starts using a concept, everybody starts paying attention. And it shows up in a United Nations report about conservation for the first time around 1990. And so the term just explodes after about this point. So this jives with our historical understanding of what happens here. Now, how do we zoom in? So this is a giant corpus. This isn't really give you a lot of leverage to understand what's actually happening with this concept. Let's take a smaller corpus. So one of the journals that I happen to have is conservation biology. So let's look at the corpus just of that. It's 5,500 articles, basically from 1987 to 2012. That's when my moving wall stops. I have all kinds of. If you want me to just complain about copyright for the entire Q&A, I could spend an hour and a half just complaining about copyright. But anyway. That's where my data runs out. But what's nice about this is this does give you, right, the late 80s bits are going to be before biodiversity is really a big deal. You're going to get to watch the concept be invented, and you're going to get to see what happens to it later. There's lots of questions that you could ask here. I just want to show you one because I don't have that much time today. But here's one. Are scientists and policymakers understanding biodiversity in the same way? So if you have the journal literature and you assume that the journal literature, for lack of a better way to put it, speaks for the conservation biologists, if that's what they think, in scare quotes, right? Now we could ask, okay, can we get a handle on what other groups think this notion might mean? Could we see other ways in which biodiversity is being deployed in the world? And could we compare them and see how they might be the same or might be different? And we can. Here's one way to do that. So this is a GIS-based way to start to think about that. Let me explain this graph and immediately give you all kinds of caveats and qualifiers. The yellow regions are the internationally recognized biodiversity hotspots. If you know the biodiversity hotspot process, right, that's very much a multi-stakeholder process. There's political influence. It's very much a sort of broad scope, a very wide net kind of understanding of biodiversity. The red, on the other hand, are all the place names that are mentioned in the entire print run of conservation biology. Now, of course, those of you, the astute among you, will realize that there's a bunch of stuff that's completely meaningless on this graph. For example, why is it that Western Europe and North America are colored in dark red? Well, that's because in journal articles, you mention the names of places where universities are. And there's lots of universities in North America and Western Europe. So North America and Western Europe are not useful data. The fact that those are red doesn't mean anything. It certainly does not mean that biologists think that there's a lot of biodiversity in North America and Western Europe in particular, as opposed to somewhere else. However, when we look elsewhere, we can start to draw some interesting kinds of claims. Zoom in, for example, onto Brazil. Everybody loves the Atlantic rainforest, right? It's both a biodiversity hotspot and it's an extremely commonly discussed topic in the journal itself. So everybody likes that. That's a great place where it looks like we all agree that it's an extremely biodiverse region. On the other hand, go look at Southeast Asia. And here we have the opposite problem, right? The result of the political process pegged a vast chunk of Southeast Asia as being a biodiversity hotspot. Whereas if you look at the number of articles that actually publish about the science, about what's happening in Southeast Asia, you see almost nothing. And now we might go, ooh, this is weird. Right? This is a sort of gap in our that we could use to inform our theoretical understanding. Maybe there's something going on here that we should just drill into in more detail. And actually, I'm hoping, I've been playing around with exactly this collection of preliminary data for almost a year now. I finally am starting to have, I think, a collection of collaborators who may be interested in really trying to unpack this project. So watch this space. There may actually finally be some more detailed discussions of this notion that I'm going to get to start working on here in the next year or two. So I'm really excited about that as well. So that's a little bit about what I do, just to give you an idea that, philosophy of science actually subject to the same kinds of questions, same kinds of theoretical structural problems that the biology itself is. So now let's do some more serious philosophy of science. Let's turn and really start to think about, what is this? What is breadth? What are we talking about? Assume that we've recognized it. Assume that these two examples that I've mentioned are good examples. They're really examples of an actual thing, an actual property of biological explanation. Breadth is a thing that's out there. How do we understand it? How should we unpack it? Now, philosophers of science have spent a lot of time thinking about scientific explanation. It's one of our classic topics. If you take a survey class in philosophy of science, you will almost certainly see discussion about theories of scientific explanation. Those theories have picked up on two features that are kind of similar to breadth. They've talked a lot about scope as a positive property for scientific explanation, and one very large, very well-known theory of scientific explanation in general has talked about unification as a property of good scientific explanation. So I want to look at both of these and then try to make the case that breadth is actually a little bit different than either one. So let me just give you a basic idea of what people are talking about when they talk about these two things. On the one hand, scope. So you might think about an example that all these theories of explanation in general, like much of the historical philosophy of science, have been developed in the context of the physical sciences. So you might think of an example like Newton's second law here, F equals ma, right, as a sort of classic high scope explanation. That is to say, this is supposed to be practically, there's even debate in the philosophical community, practically a definition of what we mean by a force. At the very least, explanations that invoke the second law are supposed to apply to literally every force in the universe, right? Let's put on our historical thinking caps for a second and pretend that we live in a Newtonian world, even though we don't really. This is supposed to apply to every single force in the entire universe. It's also supposed to ground what was taken to be one of the real advantages of Newton's way of thinking about the sciences. A high capacity for unification. So all of the different kinds of force-based explanations that you might make of in various different kinds of sciences are going to wind up sort of under this umbrella in the end, right? So every gravitational explanation has this form, gm1m2 over r squared. With the aid of the second law, that's going to give you the ability to sort of bring together gravity under this rainbow, under this umbrella of Newton's second law. We do the same thing with the electric forces. We do the same thing with all the various forces of physics, and we get this great project that lets us bring all of these what we thought were really disparate ideas underneath a single banner. So in some sense, right, scope, I want to say, and here's where I want to starting to push some daylight between breadth in the sense that I think is important to biologists and scope in the sense that might be important to a physicist. Scope, I think, is limited only by our available theories and experiments. This is something like, you're trying to push for a theory of everything. You're looking for your theoretical framework to apply to as much stuff in the world as you possibly can. Right. And so that, yeah, it's only our creativity that keeps the scope of a theory down. We would love to have more if we could, and we would immediately take it if it were available. Unification sort of looks like bringing together these various disparate examples underneath the scope or the sort of perspective of a larger, more generalized theory. And what I want to say is that neither of these really seems to be like what biology is up to. Now, why is that? Well, again, recall, and now I can be a little bit more precise. Recall when I said back at the beginning of the talk that there were these two sort of sketchy ideas of breadth, one of them being horizontal and one of them being vertical. Now let me be a little bit more precise. I think what we mean by these is that these are the limits of scope in the biosciences. That is to say, potentially a biological theory could cover all of that stuff. But when we say we want broad explanations, when we say we care about breadth in the biosciences, it seems to me we don't really mean that we just want to cover as much stuff as we possibly can. It seems to me that we're making a decision. We're making a choice to emphasize certain areas of study, to ignore certain other areas of study, for often external reasons, for reasons about what kind of science we want to be doing, what kinds of questions we think are important. We're making the call to pursue certain kinds of areas under the umbrella of our biological science and to leave others out. Now, what does that mean? If that's right, and I owe you, an entire book worth of argument that that's actually the correct way to understand what's happening here. But if that's right, what does that mean? And here's where I want to turn to a little bit of a closing idea about connections between biology and science and ethics and society. So when we look at the reasons, right, behind some of these particular choices that we make about the breadth of biological theories, we find that in many cases, they seem to be driven by social and ethical concerns, by value-related concerns, right? Here's probably the biggest value-related concern. And I probably don't have to introduce the climate stripes visualization anymore. It's amazing how powerful this image has become over the last few years. I have to seriously tip my hat that I'm not wearing to the graphic designer, scientist or graphic designer. I actually don't know the history of this, who came up with this. So it's the biggest external threat we face, right? It's a question of values, right? It's a question of deciding that this is something that we want to deal with and moving our biology to match. Obviously, since I'm spending some time thinking about biodiversity, that's really important for me. NIH's Brain Initiative. Here's one of these lovely flow diagrams out of the Human Connectome project. I was putting this talk together, and I was like, yeah, that's a suitably kind of rock and roll slide to put near the end when everybody's getting tired. Things like the NIH Brain Initiative are perfect examples of a very deliberate choice being made by an entity with a whole lot of money, who's deciding that there's a particular kind of science that they want to encourage, a kind of science that they want to support. I could go on. There's all kinds of other cases like this. For example, I think you could make the argument that the life sciences response to the overhyping and unexpected delivery, unexpected outcomes of the Human Genome Project. So we got lots of stuff, but most of what we got isn't what we thought we were going to get. That's driven by these same kinds of ethics or value concerns. People are very worried about the value structure and social structure underlying the drug discovery pipeline. People are worried about the replicability crisis and how that can be cashed out in these kinds of science and values terms. The overall point that I want to drive home, though, is that this is what happens when you are pushing for breadth, right? That is to say, biological explanations, and as an aside, I don't think this is purely exclusive to biology. I think lots of parts of the physical and chemical sciences work exactly the same way, especially the social sciences, but I'm narrowing to biology for the moment. When you are driving for breadth as opposed to scope, when you have this idea that the limits of the kind of science you want are driven by the kind of science you think we should have, then you're almost necessarily going to wind up with sort of integrated, interdisciplinary, multifaceted approach. You're going to bring together technical perspectives, of course, because you can't demand a kind of science that's technically impossible. Well, I mean, people can, but you shouldn't. But also conceptual, philosophical, historical, ethical, social, political perspectives in thinking about not just what can we do, not just pursuing scope in biological explanations, but thinking about what ought we do. We can't pursue maximal scope in biology. It won't work, right? We can't expect to have single unified theories of the entire tree of life and everything from molecules to the biosphere. We're not going to get them in most cases. There are, of course, going to be, formalized exceptions on the fringes. But in general, this is going to be, I think, the real challenge. This is the meta challenge, right? This is the challenge about how to solve the big challenges of the 21st century in the life sciences. We have to figure out how to get these people around a table and get them talking to one another. And that's not at all an obvious prospect, right? We've got to figure out how to have conversations in a society that, in the kind of open democratic societies that the vast majority of us, at least here, live in, about what kind of science we want, how we want to be doing it, and what that means in terms of the kind of breadth we should desire in the process of approaching 21st century life science. And so then we have to figure out how to get this really hard work done. And this, I think, is extremely difficult. But I think it is, again, to drive the point home one more time, I think it's a meta level challenge, a sort of higher level challenge about how to approach these kinds of big questions in the life sciences that we think so often are supposedly going to define what happens in biology as the science of the future of the next 100 years. So many thanks to the FNRS for their generous support of my lab group over the last 2 years since I got here. Thanks to my other lab members, many enlightening conversations all day, every day. And I'm extremely happy to hear any questions that you guys might have. So thanks very much.
Thank you very much, Charles. Yeah, this is the one awkward thing about Zoom, or at least one of the awkward things that you don't hear much of the reactions, but I'm sure people have many questions. Perhaps if you could stop sharing.
Sharing now. Let me
get people that. Feel free to turn on your video if you like, and we have time for questions. You will have to get your own beverages, but please feel free to ask some questions, or you can type them in the chat. Maybe I'll just start with something to kick off the discussion. So,
yeah, please.
I mean that's every biologist and scientist in general long to generalize. I think this we can all relate to. And I thought you made a very nice and powerful point about Darwin, but then you introduced this idea about that value that in biology it's not just trying to generalize, but also it becomes then value driven. I mean, is this an observation, or is this wishful thinking? I mean, in a way, I mean, it's not obvious to me that Darwin's breadth is value driven. It's yeah.
Good. No, good. Very good point. Yeah, I think I should have made that. Yeah, that's a thing that I should have made clear in the talk, because I do think I think it is a feature that we ought to wish for. Now, to what extent we actually see it or not in any particular branch of biology. Actually, I was chatting with Mark Robinson-McCavey earlier about the talk, because he couldn't be here tonight. He has somewhere else he had to be, so he wanted to get the short version. And he asked a great provocative question along these same lines, like, so what's an example of a time when people have done this well? I'm like, ooh, Actually, that's a really good and really hard question, and it's not obvious, right? There's some classic cases that philosophers of science like to point to, but they're much more problematic than everybody likes to admit. So people will talk about, the Asilomar meeting when we imposed the brief moratorium on transgenic research as a kind of example of, oh, we got everybody around the table and we really, regulated a process in a nice way. It's not even clear that that's actually what happened. There's a bunch of really good research kind of, now that we've got some distance from that event, about what that event really meant and whether or not it was really doing the thing that everybody said it would. No, I think what I would say is this is the sort of scientific process that I think we need to be able to tackle some of these kinds of grand challenges, precisely because I think we're going to wind up doing it whether we want to or not. That is to say, there's a classic anecdote, or a classic joke that philosophers of science like to make, and it's in some sense unfair, but it's also in some sense quite fair. That you can either do philosophy of science on purpose by actually thinking about philosophy of science questions, or you can do philosophy of science by accident, by not really thinking about them, and so just sort of picking default answers of sort of whatever you stumble into. And I'm afraid that we're going to wind up, as we think about how to fix these grand challenge type priorities, stumbling into that second thing, doing something that looks more like the raw pursuit of scope than a sort of careful pursuit of breadth. And I think that's a dangerous position for us to be in. I think that especially since scope can't work. This is a place where sort of physics envy gets us into trouble, right? Thinking we're going to get the grand unified theory of everything is going to cause troubles, because we're not going to get there from here. So I think that means we don't have a choice but to engage with these questions, either intentionally or just say by letting the NIH tell us what the answer to the question is, which seems like not the greatest method to make those kinds of decisions.
Okay, thank you. So you, in short, you think it's more prescriptive than descriptive.
Yeah. I mean, I would say doing it explicitly is prescriptive, but we're going to be doing it whether we do it explicitly or implicitly, whether we like it or not. And so doing it explicitly is better than the alternative.
Thank you. So I see there's a question in the chat from Sakshi Sharada. Why is it that we do not hear about many collaborations between current philosophers of biology and biologists?
They are out there. I can send you references, but no, I think this is unfortunate. Let me put my sociology hat on for a second. I mean, I think this is a shame. On the one hand, I mean, so let me okay, hang on. Let me say two things. The first thing that I should say is, of course, some of the kinds of questions that we have to engage with to be able to give clear answers to the kinds of questions that biologists are interested in aren't going to be interesting in and of themselves to biologists. And that's okay, right? So, I mean, I have to spend time thinking about, in order to understand how to interpret the models of population genetics and evolutionary theory, I have to spend time thinking about definitions of causation and stuff in manners that I don't think are very, very relevant or important to biologists. And that's okay, right? That can be part of my job. On the other hand, though, I think it is very hard to build these kinds of interdisciplinary links. So this is something that I've thought a lot about that really worries me. I mean, for one thing, professionally, it's very hard to cross these gulfs. So, for example, I feel like we could build really cool interdisciplinary projects on which biology doctoral students could come do postdocs in philosophy of science and really contribute really cool domain knowledge, and vice versa. I also feel like the postdocs who did that would probably kill their career and never get a job anywhere ever again. And that sucks. That's not cool. What do we do about this, right? How do we get around that? There's a social problem. There's a social problem there. And so I think that a lot of the problems are more pedestrian. I owe this insight to a dear friend of mine who's a philosopher of physics. A lot of these problems are, I think, more pedestrian than we give them credit for. If we could figure out how to build structures just so that we can all collaborate, so that we can talk to one another, so we can actually work together and be rewarded, receive professional credit for what we're doing when we work together, I think that goes a long way toward fixing this problem. But then I have no good answer about how you build those kinds of institutional and social structures that will actually give people credit for sort of stepping outside their comfort zone like that, getting outside their boxes like that. So I think we have like really ugly institution building kind of stuff we have to do if we really want to fix this. And if literally any one of you has any ideas about how we can do that, I am all ears, because I don't know. I really don't know, and I want to know. It's a great question.
Well, I think part of the answer is already to engage, and for that, giving this talk is a wonderful step in that direction. So the next questions, Joanna, Stephanie, in your point of view, do you think the rest of us need to add more philosophy to our everyday research? And if so, where do we find the balance, description, and explanation?
Yeah, this is great. This is a great question, and it's a challenging one for. I mean, we have the same problem on the philosophy side, right? How many biology articles do I need to read to be able to say that I'm keeping abreast of what's going on in contemporary, say, mathematical evolutionary theory? A lot, probably. Probably way more than I'm reading for real. Actually, I can say that. So this is a real challenge in both directions. I think what I would say is, it doesn't necessarily have to be direct engagement with reading or working in the literature, but for instance, in some of my discussions with some folks today, it can be as simple as, if we all can start to cultivate ways to see when, for instance, conceptual resources are starting to fail us, when the kind of when does a really nice, diverse, pluralistic concept become an unworkable mess? Right? When you think about every couple years, they get all the systematists together and they all write a book about the definition of species. And the book about the definition of species has the latest 37 definitions of species in it. And they get to the end of the book and they say, we don't know. There's a lot of them, and I guess you should just make sure you say which one you're going to use before you say species in a paper. At some point, right? That's okay. Right? There may be nothing wrong with that. That also might be a real problem. It might be impeding biological communication. It might be impeding the development of theory. It might be impeding concepts in other places, like in the study of conservation biology. If you can find those friction points, that's what philosophers of science, I think, are good at. That's where people like me can come in, because that's what we do. We come in and ask those kinds of higher level questions that you guys are too busy doing your jobs to have time to answer. And that's okay. You're not supposed to have time to answer them. But when you have them, I guarantee you there's a legion of philosophers of biology out there in the world who would love nothing more than an email and the start of a collaboration based on a real live problem in the working practice of a scientist. We would love that. Those kinds of collaborations are fantastic. And so the more of that kind of open channels of communication we can get, I think that's a great way to encourage a sort of appropriate balance. When is it a problem for you? That's when it can become a problem for us.
Thank you. So I keep on reading this question, but I mean, if some of you want to ask the question directly, please unmute and then and ask the question. I'm not like here the gatekeeper. So I don't know, Kirsten, if you want to read your question, so I'm going to do it.
Okay, sure. Yeah. Yes. So I was wondering, when you talk about values in science, and that also brings us towards funding. I was thinking about some of the bigger European grants and stuff. I mean, ultimately, who gets money is the political decision. But once it is set aside, then there is scientists reviewing who gets grants or not. And so in a sense, they get to decide what is important research as well or not. So I guess I'm asking, well, is that a bad approach? Should there be a philosopher on the ERC starting grant panel? Do we have enough philosophphers for that, or what are we gonna do?
A very good point. I mean, I think that's exactly one of the sort of spots where one of the exact spots where we've got to spend some time really thinking carefully about what kinds of science we want to encourage, because that's one of the levers that we can pull on. Obviously, it's one of the few places where you might think you could intervene in the process. There's some really interesting work too. I mean, it also depends on, again, it depends on what your values are. It depends on what kinds of outcomes you want to push. There's some great articles. There's been some really good studies about the possible superiority of grant lotteries to actually reviewed panels, right? And this may be, if your goal is just lots of sort of high impact published science papers, it may actually turn out that just handing out the money by lot is just as good as having everybody spend a month reviewing grant panels and interviewing you under crushing circumstances in some tiny office in Brussels. So I mean, that kind of thing is already interesting. I mean, here I think there's great possibilities. There's been some really cool modeling work that's been done in these kinds of directions. But again, underlying all of it, right, what a lot of the grant lottery literature takes for granted, for instance, is this idea that, yeah, so the thing that we should value is like lots of high impact science articles, and maybe that is what we should value, but also that's an open question. And I think one thing that would help would be, this isn't about, I don't think this is about the nuts and bolts of evaluating individual projects. I think it's about evaluating it's about stepping back a level from that and thinking about what the priorities are supposed to look like. But and I think the point here is actually, it's not that we need more ethicists or politicians in that process. That process has enough ethicists and politicians. I think that process needs more scientists, right? So now we're talking about getting the balance all the way up and down the chain, from the sort of really high level big money distribution kind of level down to the day-to-day kind of level. And that's hard to do. Again, these are questions about what kind of science we want to have. That there's a little bit of really good research on this. Philip Kitcher's stuff about science in a democratic society, the role of science in democratic society, is really fantastic, for example. But not enough of us, I think, are spending enough time thinking about it, and thinking about how, again, we're driven to these questions by the very nature of what it is to do research in the life sciences. So yeah. Hard, good if impossible question, but good question.
Thank you, Ted. Ted, you're next. You want to ask your question live? Yeah.
Yeah, right. I had a question about fashion. So I have this feeling that fashion is a huge driver of activity in many scientific areas. And I wondered what you thought about that, and whether interdisciplinarity is likely to be an antidote to that.
Yeah, that's a great question. I mean, and it's a great, in some sense, it's a great meta level question, in some sense, because interdisciplinarity is itself awfully fashionable at the moment, right? So there's, I mean, every university says they want it and nobody knows how to get it. So right off, no, I think that's a great point. I think it's never clear. I think it's never clear exactly what it is that drives these fashions, and that's one thing that I think makes them such an interesting challenge to study. As a matter of fact, this is a question that, I mean, so to be honest, let me lay my cards on the table. This has been for a long time now on my and a collaborator up the road, my old PhD advisor Grant Ramsey, been wanting to think about whether or not we can approach this question empirically, because it's not clear that anybody even really understands what we mean by, flashiness, sexiness, could call it what you will, right? What is it about, I don't know, what's the flavor of them? What is it about single cell sequencing that makes single cell sequencing all over nature right now? And what is it about, well, actually, we know what it is about COVID that's about to make COVID be all over nature for the next year or two. That's okay. I'm not mad at that. But it's not even clear to me that we have a real grasp on the phenomenon right now. And I want more empirical info. And so I don't know how to get it yet, because I can't quite figure out how to model, splashiness. But it's something that I think actually is ripe for this big data analysis approach, because I would love to be able, it's not just getting cited a lot. It's somehow deeper than that, because part of the point is that a lot of the high fashion papers actually aren't that good and don't get cited a lot. They're just being led into the big journals because they're on the fashionable topic. So I want to know more, but I feel like I need data. I need data to understand that problem better, and I can't figure out how to get it yet.
Thanks.
So if I may interject also a little bit as a maybe the chair's privilege here, I find the point about the collaboration between philosophers and biologists. I mean, I think we are constantly in this tension about whether we want to collaborate with someone, with whom we want to collaborate, how do we set our priorities. And I think it is a mistake to want to do something just because somehow we think, oh, we ought to do that. Right. And rather, really, it's much more productive if it covers a real need. And actually, there are lots of cases I find where, maybe a little bit like you were saying that, that you may not be bothered by values, but also, the values may be interested in you. Or I'm paraphrasing a little bit.
Yeah. No, that's good. I like that.
And so I think, of course, with respect to experiments and that you have an ethic component, it may be helpful to discuss with a philosopher. There are problems, let's say with human data, health. That's also something where we need some philosophers. I'm thinking in the course of our work, if we deal with concepts such as homology between sequences, the common, something that is a property versus something that we can, there's an operational definition. I mean, there's countless paper, I think, that could have been avoided by having also maybe some help from people who are dealing with these, the issues of epistemology. I'm thinking statistics with Bayesian versus frequency statistics, how philosophers there have really contributed also, some quite technical contributions. And then, or gene ontology, where you're dealing with the, for instance, the question of what is gene function. You might remember the ENCODE controversy. So I feel it's already very productive if whenever we are facing this type of problem in our everyday life, we can reach out and find the philosophers who may also have like the mutual interest to perhaps solve this problem. And so in that sense, I think it's wonderful, Charles, to see how you've been engaged really with a lot of the questions that are quite close to many of our interests. And I feel like already, knowing whom to reach to, maybe to even begin this process of collaboration could be really valuable.
And I think this is true for, there are a lot of different debates about, what exactly, of course, philosophers, since you might not be surprised to know that one thing that philosophers enjoy debating is what exactly counts as philosophy and what doesn't count as philosophy. But one of the, I think, of pretty common among philosophers of biology concepts here that's pretty popular is this idea that, look, philosophy of science is just sort of what happens if you go from like really hard experimental science, and then you move toward theoretical science, and then you just sort of don't stop. You just kind of keep going, and eventually you wind up in philosophy of science over here somewhere. There's a sort of clean continuum. There are papers that get published by practicing philosophers of science that look a lot like stuff that theoretical, might show up in, Journal of Theoretical Biology or something, right? And that's okay. That's a good thing. That's a feature we should want. But like you say, it's a matter of being able to know who to be able to reach out. If you don't have someone in your own institution, which often either you don't, or there's no way you ever could have met them. Like, how would you even know that they were there? How do we build those bridges? And that's something that well, I can say our professional society, philosophers, historians, and sociologists of biology, has been working for a long time about how to solve that. And we've had some real success, some great cross-disciplinary panels with, a historian, 2 philosophers, and 2 biologists or something on that are really cool. But we're still worrying about that on a regular basis, about how to construct sort of more permanent bridges.
Thank you. So Zygmunt is next. Yes.
Yeah, hello. Thanks for the interesting talk. If I can follow on those aspects of trends, I think one of the general trends in many sciences is the positive results. We report positive results, and also those unifying theories. When we know about them, that's the final solution. But we often don't hear about the path towards it and all those unsuccessful failed experiments, etc. The interesting part is that there are often many very exciting hypotheses that have been the foundation of those experiments that have unfortunately turned out negative. And so we are actually dealing with a very limited knowledge space at the end, also in the public domain. So that's the published tip of the iceberg, whereas the 90% under the water we often do not see, and public who are not scientists see even less of that. So
yeah, so this is obviously something, so you can imagine that in my text analysis work, this is something that I am seriously worried about, right? I mean, this is, any systematic problem like that with the scientific literature is going to be automatically inherited by any automated analysis of the scientific literature. You're going to be stuck with whatever kinds of patterns like that you might find. And so this is a really serious worry. One thing I can say is, at least the trend lines are good here. So I think this is a problem that's getting more and more attention. I think there's been such really neat stuff happening in the open science movement in the last 10 years or so. There's been a lot of great moves toward registered studies and all this kind of really trying to do what we can. I even saw for the first time the other day, this was cool. I actually saw somebody do a pre-registered hypothesis for a philosophy article. I was like, strong, good work. I need to start doing that. That's really cool. And so I think this is something that worries me. One thing that I'm interested in from an empirical perspective is in trying to understand what kinds of impacts we might expect that to have on the literature. So it's actually something that I've just got an article that I've been working on with a couple of my postdocs, trying to think about, even in contexts where we think there's a disconnect between the scientific literature and the rest of what's going on in the practice of science. What kind of stuff are we still allowed to say? What kinds of conclusions can we still draw about the real science that's happening underneath the publication record? And that's a hard question. That's a hard question, but I think it's one that, well, I hope there will be interesting answers to it at the end of this project. And then also, I hope that over the next few decades, we're going to get better at this. Fingers crossed.
One thing I wanted to add to this is the fact that it would be nice that this amount of work, even though it is a negative result or a controversial result, is acknowledged, because the funding bodies, especially for young scientists, they value only that tip of the iceberg, that polished publication, and that is what's taken into account. But there are a lot of interesting ideas that have been around and that people have worked and devoted their time, and that time is not quite adequately accounted for, I think, overall across sciences. And if that could be managed in a bit more fair and understanding way, that would help, I think, all of us to be, and that would help also the question of transparency and fair and just science. That would avoid that huge pressure of only getting that, very nice, sexy data that would give the publication. And yeah, that was the.
No, I think that's exactly right. I think there's it's funny, as you were making the point, it was dawning on me. It's funny how quickly you go in any conversation like this when you start to push on these questions. It's happened twice now. How quickly you get to 3 times now. How quickly you get to social, institutional, and funding structures as being so profoundly responsible for the shape of so much of what you might once have thought was the purely epistemic stuff, right? This is, if we needed more evidence that knowledge is not produced in a vacuum, right? Science does not happen in deep space. you know, all you have to do is you know, get around to beers with some practicing scientists, and you pretty quickly realize, like, no, there's a lot of very important valence here for that kind of sociocultural story. And I think how to deal with, you know, obviously there's not going to be any silver bullets here. You know, this is something that we've been struggling with for a long time. But it's important, I think, to underline how important it is. In trying to approach anything like these questions, for sure. Thanks.
Thank you, Charles. Thank you, Zygmunt, for the nice question. So we still have 38 people, 37 people on the call. I mean, it's I'm impressed by the participation. If you perhaps you still have some questions, we've run out of questions from the chat, but you know, feel free to unmute and speak out. Yeah, Joanna.
I have a second question.
We can't hear you very well, Joanna. Try to get very close to your microphone.
Is it better now?
Yeah, much better.
Okay, so thank you for the very nice talk. It initiated a lot of questions. So one other is that you were saying that we have to decide what kind of science we want. But I can assure you that I want another type of science. The person who sits next to me wants another type of science. And if I walk out, I would find 5 people that want each one of them a different type of science. So how do we gather all together to have one science that is good for everybody?
Good. Well, of course, I mean, you know, don't let me oversell it. Of course, there's so many scientists. There's still room for lots of pluralism in the scientific process, and we should, of course, encourage that kind of diversity. The question here, and this is where you get to kind of socio-political impacts, right? The question is, so what do you do? Here's something you might be worried about, and I talk about this every time I introduce this question of values in science. I just did exactly this kind of a discussion the other day with a colleague's class I was guest lecturing for. You might be worried that this is sort of you have like a Pandora's box problem here. So once you open and let in values into science, well, now you have to deal with the fact that, okay, wait though, the world is filled with terrible, racist, misogynist, horrible human beings. Are we going to wind up obligated to let them do the kinds of science that they wish that they could do, that in fact, in general, we haven't? We've been pretty good at, we try hard, maybe not great, but we try more and more to keep them from doing the kinds of science that we think are damaging socially, damaging morally, damaging culturally. So what do we do? That, all I can say is, that is an open question in the philosophy of science. This is something that we've really been struggling with over the last 10 or 15 years, about how, if we acknowledge this idea, and I take the argument that I'm making to be contributing to speaking of trends, this has been a trend in the philosophy of science literature for about 30 years now, to increasingly recognize that these kinds of social and ethical value judgments are going to infect the sciences, whether we like it or not. We're going to be stuck with them. They have an impact, whether we wish they did or not. We're not going to get back to science in a vacuum. If those arguments are right, though, then we have to ask ourselves, so how do we keep how do we let good values in and keep bad values out? And how do we regulate that decision between good and bad values with something like what we would hope would be an open, democratic social process? And that's really hard. There are lots of different proposals knocking around in the literature in philosophy, thinking about codes of conduct for scientists, or thinking about engaging scientists as a facet of democracy, or thinking about engaging public deliberative processes about science that get people who wouldn't normally be allowed to talk about science around the table to talk about what they think science is about and for, even though they may not be very well educated in the nuts and bolts of doing real science. All of these are live possibilities, and this is really a tough kind of cutting edge area of research, and there aren't any clear answers yet. But I think that's part of, in the sense that I think that becomes part of our job. That's something that we as philosophers of science are going to have to figure out how to engage with. If we like these arguments, we think we agree with these arguments, that we're stuck with these values, we'd better come up with a story about what to do with them. So we have work to do.
Okay, I see we still have quite a few people. I will soon have to leave myself to go and pick up my son, but actually I don't want to be a constraint here. So what we could do is I propose to make Charles the host. And I think as long as there are questions and the Charles is not exhausted.
I'm still running. I'm happy to take a couple more if people still have them, for sure.
I think, let's take advantage, and then, but otherwise, if we're done, then anyway, there are still some meetings that are planned tomorrow, and we could arrange one more slots in case if one of you is really quite keen also on having a one-on-one discussion. Drop me a message, and this could be arranged. And I'm going to just pass over the control to Charles, and thank you all, and say goodbye on my side. But don't don't stop now. Okay, so you're your host, so you will remain.
Yes.
And please, everyone, feel free to ask questions. I mean, you may, and in the end, Charles, end up with a few people who are just still connected, but maybe they're no longer behind their screen. So, do
sure.
close them. All right. Thank you all. Bye-bye. And see you tomorrow, Charles.
Cheers. Yeah, I'll see you tomorrow. We'll be up after my last one, so I'll look for you tomorrow.
Excellent.
Thanks.
Thank you.
Yeah, happy to take any more if anybody's got them. Otherwise, just let me know. And also, if I should have said this as well at the end of the talk, feel free to drop me an email